My name is Ian Williams. I work at the University of Southampton, where I am Head of Centre for Environmental Sciences. In this short presentation, I'm going to outline how we developed the vision for the FP7-funded ZeroWIN project. Our global economy has evolved with little consideration towards the residuals of production and consumption and their impacts on the environment. The waste we generate is enormous. In 2008, the total generation of waste in the EU27 amounted to 2.62 billion tonnes, with 98 million tonnes classified as hazardous waste. The most important sectors in terms of waste generation are construction, mining and manufacturing industry. These wasted materials represent valuable resources that we can no longer afford to discard. There's a clear need for us to stop disposing of materials to landfill and to move towards effective closed-loop resource management systems, especially within industry. This overarching big picture was the motivation for our ZeroWIN project. With the zero waste concept, today's waste is tomorrow's raw material, being central. Project ZeroWIN, towards zero waste in industrial networks, is an ambitious EU-funded project researching and trialling by means of case studies with industrial partners methods and strategies to eliminate the wasteful consumption of resources in key industrial sectors. We believe that waste needs to be viewed as a potential resource with value to be realized, and the processes which give rise to it are part of a cyclical system shown in the diagram, where resources continually recycle around the economy, and that's shown in blue, the cyclical flow. The current wasteful linear system, shown in red on the right-hand side, is one in which resources end up disposed in landfill. When we started the ZeroWIN project, many people told us that our ideas were academic pie in the sky, and that pigs would fly before the zero waste concept could be implemented successfully in industry. Well, we shall see. The ZeroWIN project work was divided into 10 discrete work packages. Each work package was led by an expert in their field. The development of a vision for zero waste entrepreneurship took place in work package 1 and formed the foundation for the entire project. Our first job was to define a zero waste system. It is a widely held misconception that the term means that no waste will be generated. In fact, zero waste means designing and managing products and processes to reduce the volume and toxicity of waste and materials as close to zero as possible, to conserve and recover all resources and not to burn or bury them. Successful implementation of zero waste should eliminate discharges to water, land or air that might be a threat to planetary, human, animal or plant health. A key part of the project was to make a comprehensive review of literature, current practice and policy so that a common vision could be created as a foundation for the demonstration activities in each industry sector. The key concepts, guiding principles, technologies, methods and tools we identified have been distilled into the key strategies that underpin the ZeroWIN approach, and these are shown in the figure. They can be thought of as a system, a bit like the solar system, with the zero waste concept at the core, surrounded by the methods and tools, etc., that affect it, and set within physical and other limitations, and of course external influences such as the economic, physical, social, legal and regulatory background. The key strategies are highlighted in red and they're shown in the diagram closest to the core. They are designing waste out of the system, industrial symbiosis, closed-loop supply chain management, use of effective waste prevention methods and new technologies, applying individual producer responsibility, often known as IPR, and accurate monitoring and assessment of results. Another representation of our key strategies is shown in this figure. Here we can see which approaches and strategies were deemed as vital for the project, and which would provide key information and ideas, and which ones might be useful but were likely to be of minor significance. The crucial ZeroWIN concept is an industrial network, a physical framework for cooperation between network members aimed at zero waste and resource conservation. The figure represents the scope and boundaries of an industrial network according to our ZeroWIN definition. In the broader economy, a number of industrial networks, often referred to as industrial symbioses, exist. Some of them evolve spontaneously if there were enough economic and political incentives. The unique thing about our project is that the ZeroWIN networks evolved as a targeted process. The development of an industrial symbiosis is usually a long-term process requiring extensive data collection, data analysis, facilitating contacts between various non-related industries, and overcoming the various barriers that need to be addressed. The ZeroWIN project deliberately targeted 4 of the most challenging sectors in terms of the quantity of waste generated and the complexity of manufacture. They are construction and demolition, electrical and electronics, photovoltaic, and the automotive sector. Our theory is that if the ZeroWIN vision can be successfully applied to these sectors, it can be applied to all others. So, to summarize, the ZeroWIN vision is to use a whole system approach to redesigning resource flows to minimize emissions, waste, and resource use. It is comprised of an underpinning philosophy, which we have published and has gone through a peer review process, clearly set out methods, scope and boundary, and an overarching call to action, a belief that waste can be eliminated in industry. You will see from our other webinar presentations how the ZeroWIN vision we developed was implemented in practice. And this figure shows how it fed into all the other work packages, but particularly into the demonstration case studies and followed by the verification and implementation. We hope you will view the other webinars and that, like us, you will conclude that sometimes pigs can fly.